Now, today's method is basically in the title. Factorize by grouping into pairs. What is a pair?
10.
Yeah, Liv? 2. Right, a pair is 2. So I'm expecting to factorize 2 of these at a time, and maybe we can see if there's any further things we can do if we factorize them into pairs. Okay? Now, if we look at this first question, if I look at A, it almost looks like I could take out x out of all 4 of them, but why can't I?
Is 6 doesn't have it?
Because 6 at the end doesn't have it. Okay? So, I'm going to read the question. Use the method of grouping in pairs to factorize these expressions. Whenever we have this method of factorizing into pairs, okay, we've got a few steps. Step 1. Separate our question into pairs. Into pairs. Okay? So separate our question into pairs. So I'm going to separate this first half and this second half. Okay, so I'm going to have x squared plus 2x. I'm going to focus on that. Over here I'm going to have 3x plus 6. Now I've just spaced them out a bit to show the separation between them. Okay, first step. Step 2. Find the HCF and factorize for both pairs separately. So girls, write this down. Okay, so we're doing that for both pairs separately. What I mean by that, you guys should all be able to do this because we just did it just then. We actually did both of these examples. How could I factorize this? Just find the highest common factor of this. What would that be? X. Great. So I'm going to have x. Then in brackets, what's going to be left over?
X plus 2.
Perfect. And then we've spaced it out. Now I'm going to factorize this expression. Liv, I got you to do this before. I got you to factorize this expression before. What did you get for this?
3x.
Yep, 3, and then in brackets, x plus 2. Oh! Okay, this is in the one question. This is the same thing. Can you guys see? Can you guys see what I see? What do you think we are going to do from here? What would my step 3 be?
X plus 2 is very similar, so you just do that.
You move to the front and then you put x and 3 at the end.
Yeah. So we're going to have, we can take out.
So it's
What's
x
that?
plus, it's x plus 2 and then 3 plus x.
I love your enthusiasm. Can you see? You're exactly right, Chase. We've got x plus 2 as a common factor of both. So, step 3.
They didn't turn it on switch.
Step 3, further factorize our expression. So, step 3, further factorize our expression. I can see, 1 second early, x plus 2. And what I'm left over with is x plus 3, which is exactly what you were saying, Chase. Yeah, it's exactly like the other question, except we've got 2 steps. We started with 4 expressions, 4 terms. We've split them into pairs and then separately factorized them. And when we do that, we can see that we can actually further factorize it into this.
Oh. Wait, how did you get the x plus 3 on the second one?
So x plus 2, I've taken them out of both. And I'm left over with x plus 3.
Yeah.
What I want you to do, as I get to Stella's question in a second, if that starting makes sense, have a go at question 2, follow the same 3 steps. Can everyone see question 2 well?
Yeah.
Maddie? Sorry, do you want me to move it up or?
No, it's perfect.
So, everyone have a go, Lockie. Turn your page over, have a go at these 2 questions. Stella? Okay, break it into 2 pairs. I'd write this all out. It's too much for your brains to try and do it all in your head. Right? Write it out, make it easy for yourself. So I'll give you guys a couple minutes. I'll start to give your answers I'll start to help out after a minute. In this first video, you will see that I'm using scaffolded teaching with my students. Specifically, I'm using the gradual release of responsibility model, which is part of explicit teaching and scaffolding. This strategy moves from teacher-led instruction to shared practice and then independent student work. The framework that is roughly done is I do, we do, and you do. In this lesson, we were learning to factorize expressions by grouping in pairs. So the success criteria for this lesson was if I could say that my students could group terms correctly and identify the highest common factor in each group and write that expression as brackets of 2 terms. In this lesson, you'll notice that I begin in the we do phase. So I've already shown an example previously. In this we do phase, you'll notice that I'm in constant conversation and discussion with my students on how to complete this problem. I set up a 3-step scaffolded solution for my students to follow that they are able to then later on follow as they try their independent work. I modeled an example on the OneNote using colored brackets to show the pairs that I grouped. In this example, I explained step by step how I would group my terms into pairs, then highlight the highest common factor in each group, and then finally factorize further to create the 2 brackets. You'll then notice that I sent my students off into the you do phase, which they gave them a couple of minutes to complete an example that is similar, just below. I left my working out on the board for students who needed extra help, but students were able to work on their own with as much or as little help as they needed. You could see students, or hear students, in the background get that aha moment where they suddenly start to understand the work as we go through the examples. And this happened at different times for different students. I chose this strategy because explicit teaching and scaffolding reduces the cognitive load of my students. This class is a Year 9 low ability maths class, so it is important that I am trying to reduce the cognitive load of my students at all times, knowing that I've got still a diverse range of students within my class. This gradual release ensures students first see a clear model, and then practice with guidance, and finally, they get to apply it independently. This is targeting the AITSL standard 1.5, which is to differentiate teaching to meet the diverse needs of students. I am going to get you guys to answer some of my questions that I put up onto the board. I want you guys to write down your answers on the show me board, okay? First question that I have. Pythagoras' theorem, what is the formula? I'll give you 10 seconds to write it down. I don't want you to put your hands up. I want you to write it. Great, hold it up. Hopefully everyone can remember it. A squared plus B squared equals C squared. Just waiting. Just waiting. Quick question. What needs to go to be, what side of the triangle needs to be substituted into the C squared? What's the special word for it? Write it down. 10. Write it down. 5, 4, 3, 2, 1. Great. The hypotenuse. Okay. Next question. I want you to show your working out as well. I want you to tell me if these 3 numbers I give, is this an example of a Pythagorean triad? Okay, so I'm going to put 3 numbers up and I want you to prove to me whether it is or isn't. I'm going to give you 3 examples. Actually, I'll just give 2 examples maybe. So you're trying to solve this on your own. So try and solve it on your own. Substitute. So don't call out. Do this on your own. Have a think about it. Use your calculators if you need it. Remember, a squared plus b squared equals c squared. I need to see working. You're working. Oh, I wasn't even. And last one. Okay, so A, B, and C. Have a think about it. Figure it out. All right. 5, 4, 3, 2, 1. Show me your boards. Show me your boards. Everyone needs to have your boards up. Lucas, put your board up. I can't see what it says.
Yeah, it's yes one.
There's a third one. Okay, I can see most people have written true, true, false. True, true, false. If you have done that, well done. I think you have done the right thing. Now, just to make sure, remember, we are substituting these three numbers into our formula, a squared plus b squared equals c squared. If the left-hand side equals the right-hand side, it means it's true. If the left-hand side does not equal the right-hand side, it means false. Okay, so for example, this one, 25 plus 49, we are wanting to figure out, does that equal 144, which we can kind of see it's not going to. So it would be false or no. Okay. Good job. Good job. In this video, I used formative assessment at the beginning of my lesson to test my students' prior knowledge of the lesson prior to this one. Formative assessment is an assessment for learning. It's for me, the educator, to be able to understand where my students' understanding is, but it's also for my students to get a gauge of where their understanding is of the content. I did this formative assessment with the use of show me boards. At the start of every lesson, I make sure to do a small formative assessment, whether it's using math space, whether it's using some quick questions on the board for my students to copy down. But in this case, we used show me boards. This meant that I could give real-time feedback and also have a real-time understanding of where each of my students' understanding was before moving on to the new content. The learning intention was to revise Pythagoras' theorem, and in particular, to state what the theorem was and what Pythagorean triads were. So I began the lesson with 3 quick questions. What is Pythagoras' theorem equation? Which I could see my students all understood pretty well. I also tested them on what the name of the longest side of the triangle is, which they successfully all said was the hypotenuse. And then I tested them on some Pythagorean triads. Some students I could see indicated that they weren't fully aware of how to complete this question. I would get my students to show up their show me board and to see their answers, and I could see a few of them were a bit unclear. So I then went on to explicitly teach where some students' gaps in knowledge were, which can be seen at the end of this video. I use this method because it's interactive, it gives me instant feedback, and it breaks the routine of working on computers and doing a lot of listening to me at the front. It's sometimes nice to break up this routine and have students interact with me at the beginning of a lesson. It also helps me to identify misconceptions early and adjust my teaching appropriately. This satisfies the 8 STOOL standards 5.1 and 5.2 to assess students' learning and to provide timely feedback. What I'll get you guys to do, can you guys pack up your stuff, grab out your laptops. All right, I'm starting in 3, 2, 1. All right, move around into your team. So count carefully, count carefully. So well done. You ready? You're right, I'll just quickly get your attention. Sam? So make sure you guys count carefully. Just pick 2 points and you're counting how high up what the rise is and how far across it goes what the run is. Remember, it's rise over run. Okay? So, 3, 2, waiting for eyes. And 1. Who am I still waiting for? Good job. You guys will have a maths-based task from today's lesson. Please make sure your accuracy is better than this, okay? Make sure you are focusing on completing the questions correctly because that will greatly help you. We are coming up to your assessment period, okay? So it is important. Every lesson counts. Keep working hard. In this video, you will see that I used gamification at the end of a lesson to consolidate my students' learning. Occasionally, I use gamification to engage my students, and sometimes I do this for consolidation, other times I use this for formative assessment. In this lesson, I made use of the interactive quiz Booklet. In this booklet, I designed this to test my students' knowledge of the rise over run gradient formula on which we had just learnt. So this was a consolidation activity. In this booklet, I used the Battle Royale mode, which automatically paired students off into teams of 3 or 4. I like this because it means that my students have to collaborate with others who they might not normally sit with. I like to mix this up because it gets my class out of the routine of sitting with the same people and actually breaks some of those boundaries between friendships, including people and helping students to adopt that collaboration mindset. Students were required to work in teams to help answer questions, and how it works is that each team would verse each other and they would have a battle royale. Each team had a certain number of lives, so in this case they had 5 lives each, and they would battle against other teams. The last team standing was the one that wins. I like this game mode because students get really into the game. Students don't just suddenly get knocked out if they lose. They keep answering the questions, and I am testing my students on their accuracy of the questions as well. The competitive spirit of the class, as you can see, kept them motivated while also reinforcing the concepts that I was wanting to teach. I chose gamification because it helps increase engagement and collaboration. It's a great way to consolidate learning and to make practice enjoyable. Students get to learn from each other while applying the concept in a fun and interactive way. This is targeting the EDSTL standards 2.6, integrating ICT effectively, and also standard 3.4 and 4.1, which is promoting student collaboration and active participation within my class.